Hello everyone. I am going to demonstrate how to perform greenfield analysis and network optimization using AnyLogistix. So what do we mean by network optimization? So network optimization is an approach which allows us to identify the best locations for facilities and to define or get the best product flows between the supply chain entities, keeping in mind that certain parameters such as costs or time periods within which the goods needs to be transferred or the goods needs to be stored. The objective is to find the best optimal configuration of the supply chain, and AnyLogistix will provide an output with the optimal location of facilities and the optimal amount of product flows for each period, guaranteeing that the constraints are not violated. The network optimization approach takes care of transportation costs, the costs associated with facilities like the setting up warehouses or distribution centers in the supply chain, the production costs, the transportation costs, etc. The problem definition can be defined not only for a single time period, but for different several other time periods connected with each other. And the default criteria for network optimization is profit maximization. However, it can be altered also to have the objective of cost minimization. In order to solve the network optimization problem, we need to simplify few things where we would consider that we won't be working with individual shipments, and then the flow of products are uniform within the time period which we are considering for the experiments. Now, what we are getting out of a network optimization, to explain this, suppose we get in the first figure, we get the supply location, the best factories, the distribution center locations, and then the probable flow of products between each of these entities till the end customer. Now, what network optimization will tell us is that the best combination or the network flow which will lead us to the profit maximization. So with this introduction, I will like to go to the tool and demonstrate how we can achieve these using the AnyLogistix tool. So when we open the tool, we see this welcome page. If we don't intend to see this welcome page every time we open AnyLogistix, we can toggle this bar so that it won't show on startup, and we can close this screen. Once we land into this, we see that there are different tabs for different kind of scenarios, experiments that we intend to do. One is a greenfield analysis, one is network optimization, one is simulation, and one is transportation optimization. What we will do, we will start with an example of greenfield analysis. We click on new scenario. So we get this window. We want to give a name to this scenario. Suppose we name this as my supply chain. We leave the scenario type as greenfield analysis, and then we can choose the period that we want to do this experiment. I leave it for a year for this current year, and then I click on OK. So what this will do is it will create a basic scenario. We see that on the left hand side, it shows the scenario. On the right hand bar, it is showing us the different tabs. One is for data, So when it is data is selected, we see the different tables, and on the right hand side we see that right hand top the map, GIS map, and then the bottom the different columns for a particular field, particular table. So now the database is categorized into three. Basic, which is like the basic tables that are needed at least to define the initial scenario. And then in use other tables which shows what all tables are pre-populated. So in this case, since we have just created this scenario without having any particular customer, so by default, AnyLogistix create a period as we selected while creating the scenario, and then the products by default it has created. So that's why in use we will see the period and products table because it's pre-populated. And under all, we see all the tables that are required for our experiment. Now, what we would want to do is we want to create a customer in somewhere around eastern part of United States, maybe in Washington, DC. To create any of these entities which we see over here. So the entities are primarily the customer, the warehouse, and or distribution centers, the factory, and then the suppliers. So normally you cannot do anything by if you double click, nothing will happen because it's in the planning mode. But if you want to create any entity, you just create on that single click on that particular entity, and then wherever you want to place it, you double click there, and it will create a customer. So what we would do is that we would remove one of them because by default, the system created one customer of Washington, DC. So we will name this customer as Washington, DC. Now, if we see the locations master data, so since we have created one customer, we will see that the location master also got updated with one location. And by default, because whatever I chose on the map, it got pre-populated with some latitude, longitude. However, if we want a particular city to be updated, so we can write the particular city with a country code, and we can update the country as well. And based on this, if we click on the toggle button autofill coordinates, what AnyLogistix will do is it will populate with the actual coordinates. So now creating such a each customer will be cumbersome. So the better idea would be to populate from an existing file of. So what we'll do is we click on import scenario and we select that particular file where the customer data would be there. And then we will click on advanced options, and then we choose, we intend to import the customer and the customer locations. So I chose those two, and then I don't want to create a new scenario, rather I want to import the data into the existing scenario. So I select the scenario name that I want to import the data into. And then I don't want to import any experiments, any initial states or any external tables. So I close those toggles, click on OK. So we see that all the customers got populated in the GIS map. Now the next step is that we want to add the product. So what we would do is that we go to the products table, and then we add we intend to do this for a PlayStation, and we update the product name, and then we
sell them in pieces, so we would make it as a pieces. And then customer and the product is added. So we would now click on create demand. If we imported customer and customer locations, we would import a scenario. We select the same Excel, and then we would import demand. And we don't want to create a new scenario. I want to insert the data into the same scenario, and then click on OK. So now I see that all the demand got populated for all the locations. Now we want to, since we manually created, we have been able to assign the product to a Washington DC location, but for the other locations that we imported, we would want to assign the same product. So what we do is control, click on control, and then click on that particular column, and then space bar. So on click on the space bar, you can select the particular product, and it gets populated for all the rows. And then we would want to, define the demand type. So there are two types of demand. One is the periodic demand, which allows you to configure the demand of repetitive nature. That is, a certain volume of products is ordered within a certain period of time. Whereas we can have another type of demand, which is historic demand, so which allows you to configure demand with exact demand data. Maybe you can get that demand data from order records from CRM. We choose Atlanta, and we click on demand type, and we select periodic demand as that is what we are that we have here. And then on double clicking on it, we have that when would that demand start. So first day, and then my demand, I will specify that every 3 days my order, I will be getting an order of 48 pieces of this product. So this demand we have to do manually. So suppose I don't want I don't want a particular value, but I want to take the value from an uniform distribution, where the minimum would be, I will say that the uniform distribution of 2 to 5 days, and then the 46 to 15 units. Similarly, we will manually create the demand types for the other locations. So just bear with me. So we have provided all the necessary data to run a Gfa experiment. What we did so far was that we have created customers, and then we have created factory. We have created demand, and then we have created a product. So we now create a Gfa experiment. We click on Gfa, and then we can select the start and end date. So assuming that we know that how many number of sites to be opened is DCs to be opened is 4. and then we select the mean measurement unit to pieces. And we click on run. So let us take at the result, look at the result page. So what it suggests is that we open the DC location. Since we have specified that we want 4 distribution centers to be opened, it has given the locations of those distribution centers. If we want to see, we click on this filter and then we click on the network. So it will show the network that which distribution centers are being served from, which are the customers are served from which are the distribution centers. Also in the table, it shows the product flow. So which distribution center is sending which product to which customer in the particular time period, and how many pieces are being shipped, and then the distance being traveled, and then the total cost estimate. We see that each of the DCs, how there are 4 DCs and they are connected to the customers. And if we intend to not specify the number of DCs, but let the experiment suggest how many DCs, rather what we would need to specify is that if we know that to meet service level or customer demand on the same day or in matter 2 days, what is the minimum distance to be traveled? So suppose each the route needs to be the maximum distance that can be traveled is 1000 kilometers. So then we specify the service distance and then run this experiment again. So we see that there is another result, and we can rename it to number. This is yeah, we can rename it to fixed number of DCs. So in the number of DCs not fixed, we see that it has suggested 3 DCs that can serve all the customers. And we similarly can see the network it is suggesting and also how it is suggesting. So and then we see that the same data by the flow of pieces from each of the local DCs to the location customer locations is being suggested. So now we want to convert this result into a scenario so that we can use it later. So what we do is we right click on this result and then convert to Gfs scenario. You can see what are the database that got filled with this new scenario. So we can navigate to the DCs and factories table, and we see that the distribution centers are populated. Right column is populated with DC. So we see that the sourcing information is being populated for the product from which location to which location. So since each of these DCs are being considered as a unique group, so it has created for each DC a different group. So this DC has a DC group, and this is a group 2, and this is a group 3. So we have covered the GFA experiment, and we can switch now to network optimization experiment. So what we do in network optimization is we identify the exact locations in terms of the roads available, the real transportation costs, the operational costs, and the infrastructure. You convert this GFE scenario to your network optimization type and modify it by adding the cost of opening a warehouse as well as the cost of processing outgoing shipment in every potentially favorable location. The network optimization will consider all the provided data to find the best solution. The experiment allows us to consider the following parameters. One is the to provide accurate results. One is actual the available roads, the potential favorable DC locations. Another is initial costs for opening a warehouse, then outbound processing costs, transportation costs, and other monthly expenses. So first we do is configure the network optimization experiment. So what we need to do is that we need to have a scenario that contains customer data, the product data, the demand data DCs, and the supplier. So we will now define alternative distribution center locations. We will create a group of alternative distribution locations for each of these locations specified. And then we will define the asset constraints in terms of what is the cost of setting up a distribution center. And then we will add a supplier. We will adjust the cost calculation policy parameters and then run the experiment. So what we do is that first we will convert this to a network optimization type scenario. So we'll right click on the scenario, GFA scenario, and then we will create a copy as network optimization. So once we do that, it creates a scenario in the network optimization tab. So it automatically switched to network optimization. So you can rename the network optimization scenario to anything you want. I'm keeping it as is. So let us have a closer look at the GFA data. So if we check the DC locations being suggested by the greenfield analysis, we see that it is being placed within a particular forest area, so which is far away from the closest highway. So we actually need to find a better location to place this distribution center. So we will consider two locations close to this distribution center. One is Vicksburg and the one is Jacksonville. We would know that these are the two potential locations that we can open the distribution centers, which are near to this distribution center, which is being suggested by AnyLogistix. Zoom into Jackson, and then we find a suitable location to place this distribution center, and we place one of the probable distribution centers, which is close to the Interstate 20 in Jackson City. So what we do is we create a warehouse or distribution center over there. And then we go to the table and we name it Jackson DC. We now go to Vicksburg City, and then we find a suitable location in Vicksburg City, another distribution center close to this highway, and we name this as Vicksburg DC. Now we have positioned two potential distribution center locations to one of the distribution centers that the Gfa experiment has suggested. Now we move into the same thing for the other DCs. So we go to this city and then to this DC, and then we identify 3 potential distribution center locations. One is in Elko, one in Carson City, and the third is in West Valley City. Have identified previously that the probable distribution centers might be in Elko, or maybe in Carson City, or maybe in the location in Salt Lake City, near to Salt Lake City, maybe West Valley City. So we first identify the one in Elko City. Identify the location where we need to put the warehouse. We name it as Elko DC. Then we go to Carson City. We identify another distribution center over here. And then we name this as Carson City DC. Now we try to see where we can put the third DC that we have identified in near West Valley City. So now we have set 3 potential locations for the warehouse that we may finally move to third DC, proposed by the Gfa experiment. We now go to the eastern part of the country where the third DC is being suggested by the Gfa experiment. So we see that it is located in the state game lands. So we need to move it to the nearest best location. The nearest best big town is Wilkes-Barre, which hosts a lot of interstate highways, and then the Wilkes-Barre Scranton International Airport also is there. So we will just hold this location. We'll simply move this location to Wilkes-Barre, which is like 14 kilometers from this location. So now we will give a meaningful name to this DC. We'll rename it to Wilkes-Barre DC. So we have completed setting up the potential DC locations. We can now zoom out and finally see the whole picture, how it looks now. So the GIS map currently shows a total of 8 DCs. So 3 of them are taken from the GFA result, and then 5 of them we have identified as potential locations. So now we will not consider the DC locations that was suggested by greenfield analysis, and then we will consider the rest. So we have successfully defined alternative locations. Now to make the network optimization experiment, choose the best distribution center locations. We will need to create a condition in the asset constraints table. And we will also specify the final number of DCs that we want the experiment to find. Since the DCs we want the experiment to choose from refer to two different locations with two independent group of customers, we must first create two groups of alternative locations the experiment will work with. So now we will create two alternative groups of locations. Now we can navigate to the groups location and we see that after the GFA experiment, it has created three unique groups. So now we will click, we will add two groups since we have two group sets of different DCs, and we will name them as alternative DCs. We'll double click on sites column and then select those DCs which we want to group here. So what we will do is that we want to group the Elko DC, the Vicksburg DC, and then the Carson West Valley, the Elko DC, the Carson City DC, and the West Valley City DC as one of the groups that we have identified. Similarly, we will create another group and then we will name it GFA DC 2 alternatives. And then we will include the other set of sites into this, which we identified as Jackson DC and Vicksburg DC. Now we will proceed to create a condition for optimizing the DC locations. We'll go to the asset constraints table. So we will add a group and then we will select the GFA DC alternatives. And then what we say is that we will need at least minimum and maximum as one. So we would want out of these three, we would want only one to be identified. Similarly, we select the alternative 2 and then we identify as one min and max. So that means out of these three potential locations that we've identified, we want only one disease to be suggested by the experiment. And out of these two, we want only one of them to be suggested by the network optimization experiment. Now it is obligatory to have a supplier to run a network optimization experiment. So we don't have any supplier. Let us create a supplier in Los Angeles area. Now we shall configure the supplier. So what we do is we can name that supplier as Port of Los Angeles. Now, since we have defined the supplier, we can choose the flow of products. So we navigate to the product flows table. We click on add to add a new row. In the source column, we select the Port of LA supplier. And the destination, we would want it to distribute to all the distribution centers. So sources 1 to 3 are automatically created while converting the GFA experiment to the scenario. The fourth we created now. And we select the products as the one that we have working with. We don't need these two locations just suggested by the the greenfield analysis experiment. Rather, we would want the alternative locations that we have identified. So first we will double click on source and then we select the alternative location. And then similarly, we will select the second alternative location. Now we will move to the product storage table. Similar to the last exercise, we will select the alternative locations that we have identified. Since we have identified the product flows from the suppliers to the distribution centers and then the customers, if we enable the connection, then we should be able to see the connection between the locations. Here it is showing the probable connections for the actual roads. So we are pretty set up with the data, setting up the different parameters before we run the network optimization experiment. The last thing to do before running the experiment is to modify the parameters of the cost calculation policy. So this can be found in the paths table. So we can see that it's pre-populated between the from and to locations, and we would want to identify the potential cost calculation parameters. So the amount of amount unit we would want to in pieces. So what we would do is that we would change it to pieces, and then we would change the cost per unit 2.002, and we are not considering any CO2 emission costs. We now define the vehicle capacity units, so we will go to the vehicle types table, and then we will change the capacity unit to pieces, and then that we let the rest to be as is. Now we go to the network optimization experiment. And what we do is that we want it to give us the 10 best results. And then we set the product statistics to pieces. And then we are all set with running the network optimization experiment. And we click on run. So we see that the optimization experiment is running in the background. And the result gets updated in the result tab under the network optimization experiment. And then we see the optimization results it has given. So these are the 10 or 6 best results that it has found. So the topmost is the best result that it has found with the constants that we have put. So we can see the network. So if you see that, if you remember that we have said that suggest only those locations, one location per DC location. So if we remember that we have identified 2 locations in this area and then 2 distribution centers in this area. So it has given the location as per the specification, and best locations we can see that in the network diagram as well. And we can see how the supply chain network is. So we see that there is one supplier which is distributing to different distribution centers, which is supplying to a end customer. we can go back to the GIS map and then we can see the other possible probable solutions it has suggested. So the difference between these and this, we can see that the second and third is that the second is has selected the Carson City DC and the Jackson DC as the two locations, whereas in the third we see that it is suggesting the Vicksburg DC and then the Elko DC as the alternative location, the third. But we see that from net profit optimization perspective, that the first one is the best one. The product flows, we see that all of them has the same product flow. Now we will specify the expenses and then compare that result. So in this phase, what we are going to do is that we will add financial information, which we will refer to as expenses of the supply chain increase. So we will specify the cost of opening a distribution center for every potential location. The cost will obviously differ from city to city due to numerous factors. Alongside this, we will specify the cost of processing the outgoing shipments for every potential location. We'll also set the cost of obtaining a product as well as the selling price. The network optimization experiment will consider the new data, which will make the result it offers more accurate. Let us start with specifying the cost of obtaining one item of the product and its selling price. So we'll specify the cost and then the selling price of this product. We will navigate to the products table. And then we specify that the selling price for a unit is $399. And we specify that the cost is $381. So far we have seen that we see that there is $18 profit for each unit. Now, if we run this network optimization experiment, we see that the profit it gives is a positive quantity as compared to the previous experiment where it was giving a negative quantity because we didn't have any profit. Selling price and the cost was same. So after specifying the correct selling price and the cost price, we see there is a profit, net profit. Next, we will specify the initial cost for setting up a DC. This will definitely affect the net profit. But we are interested in the locations, the experiment that it will offer, considering the additional expenses. So we will specify the initial expenses in the facility expenses table. So in the first column, we will add the Carson City DC. Set as a initial cost. And then we will set up a value USD to set up the facility in Carson City. Similarly, we will add another location, set it as initial cost, and then set its cost. Now we have set up the initial cost of setting each location. We will now go to the DCs and factories table, and we will say that these DCs are not initially open. Otherwise, it will never consider that the cost of opening each of the DCs. Now we will proceed to specify the cost of processing outgoing shipments. So we will navigate to the processing cost table. We set all of the products, one that we are working with. We set the unit to pieces. We set in the individual cost for outgoing shipments at each of the locations. So we have set up the outgoing cost, and then we have set up the cost of each of setting up each location or each facility, and also we have specified the selling price and the cost price of a product. Now it's time to run the experiment. So now we see that the net profit again went down because it is quite obvious that it will go down for setting up a new facility. And then we see the network. If we compare with the topmost result given by these two results, so we see that the top result given, so it was suggesting Carson City and then Vicksburg, whereas this one is suggesting Elko and Vicksburg because it has considered the cost of setting up a facility expense. We can enable the map and see the paths and the location of the Vicksburg that each of the DC locations are serving to. So what we have done is that we have found the best supply chain configuration using the optimization methods. The received result has considered the suggested warehouse locations, then actual available roads, the transportation costs, the opening costs for the sites, and the processing costs, as in the outgoing shipment cost. Now we will convert this optimization experiment result to a scenario. So since this result got converted into a new scenario, so we can observe the data. Basically, there are changes to two tables that got additional data. So one is that the site state changes. So if we see that table, so it has got populated with those DCs which finally the result was obtained. So if you go to the top result of the last experiment that we ran, so it suggested Elko, then it suggested Vicksburg, and then it suggested Wilkes-Barre. So if we see over here in the sites state changes table, so Wilkes-Barre, Vicksburg, and Elko. So if we now go to product flows, we can see that what are the locations that Wilkes-Barre is sending to by putting a filter on the source column. If we click on the detailed view, we can observe the DC throughput. So the fixed value column contains the throughput of each of the source. So we have now completed the network optimization experiment.